Hello guys, welcome to Miscellaneous UPSC. Today we are going to learn about a very interesting topic, that is formation of fog, clouds, mist and smog. Actually, all these condensations are same, but the way they form and the kind of characteristic they show make the difference. Okay, the formation is absolutely the same, but the difference is how they form and where they form. Okay, today we are going to learn about them. Let us go into. Okay, first, before knowing how they form, we have to know about the definitions. This definition. First, you know what is humidity, right? What is humidity? It is a moisture present in air. That is what simple. Okay, we are going to furthermore. What is this absolute humidity? The actual amount of water vapor present in the air is commonly referred as absolute humidity. That is this amount of humidity present in air. It may be grams, kilograms, whatever. Okay, next, relative humidity. Relative humidity is the percentage of the amount of moisture that air could hold. I will give a good explanation about this. See, suppose let it be a temperature of 25 degrees. Here this is the air. Okay, air. At this point, this air is filled with half amount of uh, half its space with moisture. Okay, how much is left? How much still? How much space is left in this air? This is the thing, right? Let it be half, and this is half. Fine. Now, what is relative humidity is saying is the actual amount, actual humidity by total its capacity, total capacity. Okay, what its capacity? That is this whole half plus half. Let it be 1. So what is the actual humidity present, vapor present? Half. This is the definition. So what is the relative humidity of this air? 50%. Okay, here will be 100. Okay, 50%, right? 1 by 2 is 50%, right? 0.5, that is 50%. This is what relative humidity, because this is very important. Okay, we have to know about this thing. Fine. Okay, we learned about relative humidity. Okay, let us go further. Fine. Again, this what is the this is the air, some amount of air. Okay, air at temperature 25 degrees. Okay, it is having a, let it be half amount with moisture, half. Okay, suppose this air gets some more heat and its temperature increases to around 30 degrees, its capacity will increase. Means its capacity is increasing, but the amount of moisture is present already is same. So it gets it occupies less space, the amount of moisture present already. So there is lot of space. Let it be 75% is left and 25 only is filled. Here half is filled. So with temperature increase, capacity is increasing. Fine, right? And even relative what? Relative humidity is also decreasing, because 25 by 100. What is this? 1 by 4, right? That is 25%. It reduced from 50%. Means this is what happening. Okay. Till here we got. Okay. Next. This is what you have to remember. Temperature increases, its capacity increases wherever you go. Temperature of air increases, its holding capacity of what? Moisture increases. Okay. See how it has increased. This air is like, because we already know, right? If heating happens to any air, it expands. It expands. Cooling is done, it compresses. This is the thing. Okay. Next we will learn about what 100% HC, relative humidity, that is dew point. Okay, fine. Okay, till we have learned, right? Suppose, what is dew point? Suppose this is this is cloud, right? And it is completely filled with moisture. That means its relative humidity is complete, right? 100%, 100, I mean full amount by full amount, that is 100%. So it cannot hold anything. So what does it mean is, it means it will be at temperature T. Okay, dew point, a point where relative humidity becomes 100%. Its whole air is filled with moisture and there is no space for moisture. Capacity holding is 0. Then it is called dew point, and the temperature is called saturation temperature. Okay, saturation temperature, dew point, and 100% relative humidity are same. Okay, these are correlated to each other. Fine, you understood this thing. Okay, now we will understand how clouds are formed. Okay, clouds are formed. See, let it be this ground. Okay, due to insolation, insulation, vaporization is taking place. So this wind is carrying moisture, and at some point this is what happens. So when this happens, complete holding capacity of this this thing is reached. That is what we call condensation. Means there is no place to hold. So all the moisture present there will come together and form droplets. How this air is moving up, moving up, moving up. The with altitude, what happens? Temperature reduces, right? With altitude, temperature. So this condensation will have, because with temperature, capacity holding will decrease. Decreasing temperature, capacity holding will decrease. See, this is the holding capacity of this air. By decreasing temperature, its holding capacity is reaching. Set at point, what will happen? There will be overflow. Suppose this is a glass filled with water. Suppose if you are pouring this water in this kind of vessel, what overflow will happen? That is what happens if temperature reduces and its capacity holding will decrease and burst will happen. That is what rain. Okay, we understood. So what is this temperature? Let it be 3 degrees. Okay, here it is 0, here it is minus. So according to capacity, this thing will form. We will not name it as cloud because there is something we should know how the cloud forms. Suppose we are thinking about this as a condensation. Okay, because cloud, fog, smog are the forms of condensation. Okay, we are only thinking about this condensation. Suppose this condensation happens in minus degree, minus temperature. So this is a freezing point of what? Water. So crystals will form, that is ice. If its holding capacity reduces, this is what happens. We can call Vadagallu. If these ice is huge, we call it as hailstone, right? Hailstone. See, according to this forms. Suppose any condensation formed near. So we are. Let me see my word. I'm not at all using cloud or anything. I'm just using condensation. Okay. If this condensation takes near the ground, that is called fog. If it takes at altitude, that is clouds. Fine, that is the difference. Okay, let us go into some other picture. According to height, name of that condensation will change. Remember, condensation is associated with clouds, fog, mist, we can call it another thing, haze, whatever. But they are according to their altitude, their name changes. This is what we have learned previous, right? Capacity holding capacity. And when we learned about dew point. Now, how this moisture is forming a drop. Suppose you must have seen a glass with cold water, right? On that there is water drops. So for that moisture to form water drop, it needs a support. For here the support is glass. Suppose what is the support for water drops, raindrops? That is dust particles. Dust particles. Okay, this is the dust particles. That's the reason you must have heard about cloud seeding, right? Because there is moisture, but there is no holders, supporters. These supporters are called hydroscopic particles. Hydroscopic particles. That is the reason you must have heard, right? For they say artificial rain, that is called sprinkling of silver iodide. With aeroplanes they will seed, so that there is a support for that moisture. That is what this hydroscopic. Here in this glass, what is hydroscopic? That is, glass is the hydroscopic because it is supporting water. Here what is for rainfall? Dust. So here there is no, this is a cloud, there is no dust. So they are through aeroplane they are releasing dust, or that chemical is silver iodide, with which water drops are forming, or else there is no support to form because it's something they have to hold. That is what this hydroscopic thing. Next, explained, explained. Fog. Now, see, fog is a collection of liquid droplet or ice crystal suspended in air at near the Earth's surface. I told, if cloud forms here, that is called not cloud. That is condensation forms here. Means uh, all the moisture coming at one place and forming drops. Okay, that is called fog. Suppose here the dust particles are replaced with, that hydroscopic particles are replaced with smoke. What we call them? We call smog. It This is what happening in Delhi, right? Due to stubble burning. That is the situation. This is how fog forms. See, fog is forming near the ground. Okay, then why fog is present throughout the day? There is even other thing, because when only in early mornings we find what, fog, right? When sun comes, sun will increase temperature of this condensation fog. So temperature increases, what will happen? That that condensation fog will become huge and disperse, because its holding capacity will increase and RH will reduce. So for condensation, what is the requirement? RH should be more than or equal to 100%. If it reduces, there will be no. That's the reason in winters only we find fog, because temperature is high, clear sky, even good amount of hydroscopic particles are there. Next, low temperature, then holding capacity will reduce and condensation will form near the ground. That is what called fog. That is the reason after sunshine all the fog will disappear. Simple, right? This is how it goes, friends. I hope you like this video. If you like this video, click on the like button and subscribe and share my channel. Thank you. All the best.